Hi everyone, welcome to the Logistic Regression in Python. For this lecture, we'll be working with the Titanic dataset from Kaggle. This is a very famous dataset and very often it's a student's first step in machine learning. We'll be trying to predict a classification, survival, or disease in this case. And also we'll begin our understanding of implementing logistic regression in Python for classification. So for here, if you're not familiar with classification, I strongly suggest you to do some reading on that topic. Okay, so here I have imported some libraries, NumPy, Pandas, Matplotlib, and Seaborn. And let's start by reading the data set into a Pandas data frame. So we'll use a semi-cleaned version of the Titanic data. Here I will declare a variable called train and pd.read CSV. And the name of the CSV file is Titanic underscore train. Okay. And then we'll take a look of the train. So we got many columns here. Passenger ID, is the passenger survived or not? 0 is not survived, 1 is survived. Passenger class 1, 2, or 3. And the name of the passenger, their gender, their age, the number of siblings or spouses they have, the number of parents or children they have, the ticket number, the price of the ticket, the cabin number, and the embarked city. Okay, so far we just read the top 5 rows of the data frame, but I have already seen some NaN here. Okay, so when I do the exploratory data analysis, I'm probably gonna start by checking out missing data. Okay, so why not just let's call the data frame and use the method called isNull. So this method is gonna return the boolean true or false. So we'll have a data frame that shows true or false. So basically means is the cell null? If that's null, it will return true. If it's not null, it will be false. Okay, so that will be something like this. So, and I feel like it's pretty hard for us just read something like a true false table, right? So I strongly suggest you to visualize it. And here I suggest the heat map. So SNS heat map, and I'm gonna put this into the parenthesis, and also I'm gonna add some other arguments. So the first one will be C bar. I don't actually need the color bar in this case, so let's turn it off. And we don't necessarily need too many tick labels, so let's set y tick labels, set that to off. Okay, and also CMap, I would like to have the color vary this. Okay, let's take a look. So here what we have is the dark background, and also we got some yellow dashes here. So each yellow dash represent a real missing data point. Okay, so here we got let's say 2 columns, they're missing data, the age column and the cabin column. I'll say roughly 20% of the age column is missing, but the proportion of age missing is likely small enough for reasonable replacement. Could be with some form of imputation. But when we look at cabin column, it looks like that we are just missing too much of that data. So we can't do anything pretty useful with a basic level. So I will probably just gonna drop this one later. Oh, I will change that to another feature. Could be like cabin none, 1 or 0, I don't know. Okay, but now let's just continue with some visualization to explore the data set a little bit more. We will leave this question on how to deal with the missing data to the second part. Okay, so to do some visualization, the first thing I'm really curious is probably the target variable, which is our survived. Are you survived? Or is the passenger survived or not? Right? To visualize this one, I will probably suggest by using count plot. So it's gonna return me the number of passengers survived. Let's take a look. So I'll set X to be survived. Okay, and the data is string. All right, so here we got the count plot, and we can see that people who did not survive, the number of people who did not survive is over the people who survived. Okay, it's around let's say 550-ish, and people who survived is just 350 maybe. Yeah. Okay, and based on this, I could also fill in another argument called hue. Then I would take in something like a sex. What is that the name of sex? Oh, sorry, I should capitalize this. Okay, so here I can see how many male is not survived, are not survived, how many males survived. So you can probably see that the number of female who survived is more than the number of males survived right here. Okay, and just like that, I can replace it with P class. Okay, for this one, I think it's actually makes sense, right? You can see class 3, the people like in class 3, most of them they are not survived. The people who are in the first two classes, the first and second classes, the chance for them to survive is higher. All right. Okay, so this is for the count plot, and I can do this plot on the column H, right? So SNS this plot train age, but as I said, we got some missing data, so I am just gonna drop the not applicable numbers so far. And set KDE to false. I don't actually need that. Okay, so that is the distribution, the this plot for the age column. Okay, you can see people here mainly from 20 to 40, right? Okay, and we can do histogram. So train dot. So that's gonna basically give you the similar stuff, but I'm just gonna show you can use another method to do so. So still on the age column, dot plot, dot his, right? This is the pandas visualization, and I can set the bins to 30. Okay, I can set something like alpha. I'll set that to 0.8 maybe. Right? Okay. Just use some visualization that comes to your mind to do some exploration, right? And I can use another count plot for the SIP data equals tree. All right, so how many siblings do they have? So most of the people, they don't have any siblings or spouses, or just got one on board. Okay, and also we can do another histogram on the fare, the ticket fare. So east set to 40. Oh wait, I didn't. I spelled something wrong here. Yeah. Oh no. Okay, so it's the F is not capitalized. Oh, maybe I can add the fixed size. I'll set that to 12 for. All right. Okay. Too much, but you can do your customized fixed size. I just want to show you that you can put that as an argument. Okay, so here you can see the ticket price, right? It's mainly, I think Bing's 40 is too much. So 20. Okay, now better. So I think it's more, I can do 10. Yeah. So, oh, 10 is too small. So 20. Okay, so it seems like everything focused at 0 all the way up to, I guess, 30 something, right? The price is over $500. And when the ticket price gets lower and lower, not so many people got the cheap ones. Okay. So here are the basic exploratory data analysis based on visualization for this data set.